Okay, so now we're looking, instead of at that flat 2D graph, we're looking at this 3D grid, and Mathematica actually allows you to do these visuals with the 3D grid. Obviously, it's not too hard to see what it looks like.
Yep.
And here's that degree distribution that we looked at yesterday.
Mm-hmm.
And then here's what this looks like for this one. So on this graph, low number of infections up to higher number of infections per step.
Mm-hmm. So it's the same general behavior, although maybe with a higher peak here.
It's interesting when you scroll like really far. It seems like the entire population gets infected around here, and then it just sort of curves down from there. So.
Yeah, so this is our maximum. So this is basically everybody's on average meeting one person per step. And I think the way this is set up is the infection, I think it lasts for 7 days, maybe it was 8 days, but something like, let's say 8, just for fun. So if you're meeting one person per step on average and you're infected for 8 days, how many people are you going to infect? Probably
8 people.
Yeah, 8 people.
8 people. And so what happens? What can you say about the shape of the infected, uninfected, and basically not able to be infected anymore people over time?
Well, I mean,
So why do you think it falls like that?
I guess there's just a point where you have so many people infected that you just are infecting many more people and they all get better, so it falls pretty quickly. Like you have a lot of people getting infected and a lot of people recovering at every step.
Yeah. Does that make sense?
Yeah.
Okay, and then let's look at the, here's the graph again of total infected, am I on screen? Yeah. Total infected, and then peak infected. And you're right, the peak does seem to be higher here.
Yeah.
And well, what else can you say about these graphs for the 3D grid?
It's the same general shape as the 2D grid. I mean, the peak is sort of, kind of has this almost logarithmic pattern to it, like starting here. And then the total is sort of the same, where you have this critical area, and it goes from no one to everyone pretty quickly.
So what's that saying? At that below the critical area, what happens to an infection?
It just doesn't happen. There's almost no one gets infected.
Yeah, so even though I start out with 1% of the people infected, the infection just tends not to spread.
Yeah.
Mm-hmm.
Now, granted, this is only one run at each time, so we would have to be a little more careful, but you can see the general shape. And if I'm above that threshold, what happens?
Everybody gets infected.
Yeah, it
pretty
just spreads.
fast.
It spreads everywhere. So, okay. So let's look at the Delaney triangulation next.
Okay.